All right, moving right along. Um, Pay attention to the directions. It says factor. So when I look at this, just like what I set up in the previous one, this is a binomial divided by a binomial, exactly the same thing. This could be considered a binomial. Two terms. This is a term. All right. So when you look at these two terms, what you have here is called a GCF, sine squared. You pull that sine squared out. That gives you 1 when you undistribute this. Then this gets you cotangent squared all by its lonesome. Well, with that 1. All right, but you pull that sine squared out is what I meant by that. So really have to be able to see that. It's just like z plus qz. Z is a common factor. When I pull z out, I have a 1 there, and then I have a q by itself. All right, and the reason I always say good distributors are good factors, because they check when I distribute this back, do I get what I started with? Yes. So that's what, GCF factoring, I say unfoiling, might be illegal, but good FOILers, good factors, all the same. And then just one more thing, the Pythagorean theorem with x, y, and r. Just to know, you're supposed to know these like the back of your hand in my class. If I decided to divide by y squared both sides, this was our deriving these formulas. So yes, x over y is cotangent. Y over y squared is 1. So what is r over y squared? And the answer to that is cosecant squared. So yes, 1 plus cotangent squared does equal cosecant squared. So after one little bit of factoring and one Pythagorean identity, these two are reciprocals of each other. So you get a simple little 1 for that one. And that's all she wrote for that. Factor is the key thing in the directions. So what we do here is this is a difference of two perfect squares. We've talked about that since August. All right, factoring every day last semester almost. Well, 3 times a week, I would say, on average. And the difference of two squares looks like this. I don't know why I'm writing cos. That's a brain misfire. Secant squared. And then tan squared plus secant squared. At least in these questions, I have a little more room to work. I probably should have done that with the worksheet. But I like making it so it's like 2 pages only, so we have everything condensed and, blah, blah, blah. Okay. Oh, this gets a little tricky now. So the Pythagorean identity that I have memorized, which you should as well, is this one. So when I subtract tangent squared from both sides, this is what I get. I'm going to erase this. This is how I think. This is my thought process. So if 1 equals secant squared minus tangent squared, then when I multiply both sides by -1, I end up getting that. All right, so this is actually equal to -1, and that's what I'm going to replace it with. So this becomes -1, not 1. That's the most common wrong answer for this. And then what do you do from here? The directions were just simplify. I know some people might start changing this into terms of sine and cosine, and that's where this gets a little tough when it's not a multiple choice here. And the directions didn't say anything, leave your answer in terms of sine or cosine. Although this is sine squared over cosine squared, this is 1 over cosine squared. Then when you distribute a negative, I could see you doing that. But really, the idea was we wanted you to factor a difference of two squares and then understand that there was a little sneaky Pythagorean identity in there. So this would be an acceptable answer. I'd also take that this is sine squared over cosine squared. This is 1 over cosine squared. If you decided to go further, then it would end up being this over cosine squared. Not both negatives. A negative over negative would be a positive. So only the negative would be up in the numerator. But that's where it gets to be troublesome when it's not you know, a matching. But possible answers are acceptable, many possible ones. But that's all we really wanted you to see. Difference of two squares, and then that this is equal to -1. This is one of my favorite questions of all time. Love this one. And I really hope you recognize right away that I have cubes and I have a difference. So therefore, this is called a difference of two perfect cubes. Okay, soap. So the first that I have not given myself near enough space here. So perfect cube of the first, same perfect cube of the second. Same as the sine. And hopefully you remember this little thing that I don't know how that turned into, no, that actually should be an x. And how come that's a theta? All right. Then the next term is just this squared. And the reason is simple. What is cosine squared times cosine? And the answer is cosine cubed. And then opposite, which is plus, and then it's these two multiplied together, which is cosine sine. And then always positive at the end, plus, and then it's this squared, which is sine squared. And the reason is, I'm really covering the front end and the back end. And that's usually when people do something completely wrong on this. You don't even come close to what the answer should be if you multiplied it out. Cosine times cosine squared. Negative sine times sine squared gives you the negative sine cubed. All the other distributions would end up canceling. Sorry, lack of a better way to say that. So you don't always have time to check, but I always get sad students that don't even check that they even have a sensical answer at all. Then you look at the multiple choice, and then here comes the panic. Oh no. Well, maybe I made a mistake. Maybe it's not always positive at the end, so I'll circle B. Wrong. Always positive is always this sign here, so there's something amiss. And what it is this. Sneaky Mr. Samulus and all the other cat teachers. Cosine squared plus sine squared is 1. So when I turn that into 1, that turns into the letter D. My favorite question. One of my favorite questions of all time. Okay, I don't know why I'm breaking this up the way I did. I just little short videos for each little section, I guess. So we'll stop there.